B, what we have on B is we have a graph that looks like this. On any, before we do the absolute value, this is what the graph looks like. All logarithmic functions will look like this. It'll go through my base, it'll go through my base. No, it goes through 1, sorry. It goes through 1. And then I have on all of my logarithmic functions, we'll have a look that looks like that, and I have this vertical asymptote here. All of them have that vertical asymptote without a transformation at x equals 0. So what do you think the absolute value is going to do to my graph? Is it going to do anything to my graph? What is it going to do to my graph when I have the absolute value on that?
All the values between 0 and 1 will be up above the x.
So it takes this portion of the graph, which is currently below, and it makes them positive. So what it does to the graph is it does something like this. So it's going to do that to the graph, yes. So that part of the graph, yes, that is below will be a reflection across the x-axis, yes. The part that's already above and positive, it will stay exactly the way it is.
So it's just part of the function that gets
Yeah, it is the only part of the function that gets reflected is the part that's negative, because my outputs are now being forced to be positive because the absolute value symbol's there that says I have the absolute value, so any value that would have been as an output, a y value that would have been negative, now becomes a positive value. So with that information, find the limit as x goes to infinity and as x goes to 0 on this one. Because this one doesn't go to negative infinity, the limit as x goes to infinity and the limit as x goes to 0. And again, the reason that happens is because that's what the graph looks like. I don't get to go to negative infinity. So on a logarithmic function, as x goes to infinity, where is that going? Is that going up, or is it going and approaching a number? It's going up without bound. So on the logarithmic function, in particular, the natural log is what we're looking at, is that because it is a logarithmic function, as x goes to infinity, it's going to positive infinity without bound. So on B, you would do the limit as x goes to 0 of my function. And looking at my graph, where does that go? It goes to positive infinity. And then the limit as x goes to infinity of my function, where does that go? It also goes to positive infinity. Oh, I didn't want to do that. Okay, so on C, what you want to do is you want to write this as 50 times e raised to the negative 2x. The reason you want to do that is because exponential functions all look like this, in which they're going to go through whatever their base is, provided, of course, their exponent is positive. So if their exponent is negative, in this case, what does that do to my graph? It has a reflection across the y-axis. So that negative is going to take it and do this to it. So then you can find the limit as x approaches positive and negative infinity on this one. I can't do that with logs because negative infinity is not in the domain of the log. But for exponentials, negative and positive infinity is the domain in there. So when you do the limit as x goes to negative infinity of my function, based on my graph, where does that go? goes to positive infinity. And then the limit as x goes to positive infinity, it goes to 0. How is that? Is that okay? So do D and E, find the limit as x goes to positive or negative. On D, I am looking for the highest power in my denominator. What is the highest power in my denominator? So I'm going to divide all of my terms by x to the 4th. X to the 4th here, 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 here. Magic marker, it's not. X to the 4th. What I end up with by doing that, I'm not going to take the limit yet, I'm just going to show you what I'm doing algebraically, is on my first term in the numerator I get a 1, and then minus 4 over x, that cancels into 1 over 4 over x, and then plus 1 over x to the 4th. Any questions so far? In the denominator, I'm going to get 2 over x to the 4th minus 2 over x squared minus 7. Now I'm going to let my x run to be a very large number, which means I'm dividing each one of those terms that has an x in the denominator by a very large number. As x runs to very large numbers, that will equivalently go to 0. This one will equivalently go to 0. This one goes to 0, and this one goes to 0. My final answer is going to be 1 over negative 7. So that's where it goes. So 1 over negative 7. How is that? Yes?
Can you like us to write it as 1 over negative 7 or just negative 1, 7?
I don't care.
Okay.
So the question was, does it matter where the negative is? And the answer is no, because I just have, basically, I have something that looks like this. I have a over b. I can put the negative on the denominator. I can put it in front, or I can put it in the numerator.
Okay.
So wherever you put it, it's fine. This one, on E, what is the highest power in my denominator? It's only x. I'm going to divide this by x, this by x, this by x, this by x, and this by x. So I end up with a limit as x goes to infinity of x minus 2 plus 5 over x over 1 plus 2 over x. When we let x go to positive infinity, get to be a very large number, the things that we're going to go to 0 is the 5 over x and the 2 over x. That'll both go to 0. What happens to the x in the numerator that's by itself? Where does that go? It's going to go up to positive infinity. So this one is not going to go to a nice y equals a horizontal line. It's actually going to go to x plus 2, and so this goes to infinity. Equivalently, if I wanted to do the limit of the same function as x goes to negative infinity of this, it's going to go to negative infinity. So choose a very, very large positive number. When you put in a very large positive number in this first top one here, if you put in a very large positive number here, I'm going to get a very large positive number minus 2 over 1. So it's going to be a very large positive number. If I put in a very small negative number, say negative 1 million, it's going to be negative 1 million minus another negative 2 divided by 1, which gives me a large, in terms of the magnitude, negative number. So a very small negative number. Okay? Does that answer your question?
Yes.
Okay. The last three, and then we'll go into 2.4. On F is like I did yesterday, is I'm going to factor out an x squared out of the square root. So when I factor out an x squared out of the square root, I'm just going to do that actually. I'm going to do that right up here. Let me move this up here. I have initially 4x squared minus 1. I'm going to factor out an x squared, so I have x squared, and then I have 4. Now when I'm doing the factoring, what I'm doing is I am dividing by x squared. Yes, Max?
Are you able to pull out the 4x squared element stuff?
You can.
Okay.
Do I want to? No, I don't feel like it. But it's not wrong.
All right, I just wanted to.
It's not wrong. It's not wrong. Okay, so what I end up doing when I am factoring is I'm dividing each term by whatever I'm factoring out. So if I'm factoring out an x squared, every term needs to be divided by that x squared. If I'm factoring out a 4x squared, then I need to divide every term by 4x squared. Okay? So once I've done that, then I know that this is going to equal the limit as x goes to negative infinity of the square root of x squared 4 minus 1 over x squared. This is all over x plus 2. How are we doing so far? Is there any questions at this point? Anything at all? All right. Now, because of the fact that if I have the square root of a times b, I can write this as the square root of a square root of b. So I'm going to distribute the square root. And when I distribute the square root, I'm going to get the limit as x goes to negative infinity of x 4 minus 1 over x squared over x plus 2. Yesterday, we went over the rule that if I have an index, which is this right here, if that index is even, in this case it is, if my index is even, and when I factor out and take the square root, 4th root, 8th root, or whatever, and my power on my variable is odd, I have to do the negative and the positive of it. That was the rule that we went over yesterday. So I'm going to negative infinity. So what I'm really doing here is I'm doing the limit as x goes to negative infinity of negative x, 4 minus 1 over x squared, x plus 2. If I was going to positive infinity, I would have the positive x, square root of 4 minus 1 over x squared. So when I do this, I still need to divide everything by x, because that is the highest power in my denominator. So I still need to divide everything by x. So I'm going to divide this by x, and then when I have negative x square root of 4 minus 1 over x squared, and I'm dividing the entire thing by x, this is a multiplication of two numbers. So if I were asking you to do the multiplication and divisions of AB divided by B, you would be able to cancel those B's out, right? Because it's a multiplication. Equivalently, that's what's happening here, because it is a multiplication between x and the square root. So I'm allowed to do that. Yes, James?
How would you factor it before you divide that?
Why would I factor first? Well, I don't really have to. I could have divided everything by x, but if I divided everything by x, I've got to be able to bring that x into that square root part. So it's better to just pull it out first and then do the division. You can do it the other way. Absolutely, you can do it the other way. So what I end up here is when I divide this numerator by x, I'm going to have the limit as x goes to negative infinity of negative square root of 4 minus 1 over x squared over 1 plus 2 over x. As before, as I let x run to a small negative number, this term goes to 0, this term goes to 0, and what am I left over with?
2 over 1 plus or minus.
So I get the negative square root of 4 over 1, so in other words, I get negative 2. Had I done the limit as x goes to positive infinity, then I would have had the square root of 4 minus 1 over x squared all over 1 plus 2 over x, and this would have gave us up the positive 2. Okay? So up here, I'm dividing everything by, so I'm just gonna backtrack. So she asked what happened to the x in front of the square root. On this step, let me do it in a different color. On this step, I am dividing every term by x, numerator and denominator. And the numerator, I just have one term. It looks like it's a bunch of stuff, but it is one term. So up here, I did it off to its side, so you can see the fact that I really just have one term. It is negative x times the square root. Since I have a negative x times the square root, I am dividing by x. My x's will cancel in front of the square root and then in the denominator.
That is not the denominator. That's what I was getting confused about, because the denominator, I got the denominator part right, but that I did not understand how that happened.
Yep. Are we good?
Yeah, we're good.
So that's what that looks like, and this is on the test. Is there any questions on this? Yes.
See, what I did first was I pulled out 4x squared.
That's fine.
And I did it in 3 steps. It makes me feel like I'm missing something.
No, I'm just putting a lot of steps in. So I put a lot of steps in when we're first learning something, and what you're going to see later in Calculus 2 is this kind of steps I won't do. I'll just go right to the work. But in this, you all have experienced and have been exposed to your pre-calc 1 and 2. How many of you remember it? Exactly. So that's why I put a lot of steps in right now. So right now I'm putting a lot of steps. You'll see toward the end that I won't put as many steps in because you will have been refreshed with all your algebra. So that's why I put a lot in. So Max, you could have got the same answer as me, shorter. I expect that. All right. Going back to this lovely. What is the highest power? It is x of 1, so the highest power is 1. So I'm going to divide everything by x. Now again, this is some algebra that's going to go on here. So I know the square root of x is the same thing as x to the 1/2. And I also know if I have a to the m, a to the n, I am subtracting exponents. And I also know if I ended up with a negative exponent, I write it as 1 over that a value to a positive exponent. And the reason I'm reminding you all of that is because when I come up here and I start doing the division, I'll wait till you have all had an opportunity to write that down. When I start doing the division by x, you're going to see that I'm going to have square roots in denominators, even though there are square roots in the numerators now. I'll explain when we get there.
Can you zoom out for a second?
Zoom out. All right, so when I do this, first I'm going to try to see if I can erase this other stuff so I can have space. Okay. When I do this one, I'm going to write my square root as x to the 1/2 everywhere I see it. So I'm going to write this as the limit as x goes to infinity of 2 times x to the 1/2 over x minus x to the 1/2 plus 1. When I do the division of my highest power, which is x, so I'm going to divide everything by x. What I'm doing is I'm doing 1/2 minus 1, which gives me a negative 1/2. So let me say again what I'm doing here. So when I have x to the 1/2 divided by x, this is x to the 1/2 minus 1, which is x to the negative 1/2, which is 1 over x to the 1/2. So I basically, what I have is I have 1 over the square root of x. How was that? So when I have x to the 1/2 divided by x, I'm using my rules of exponents that says I'm going to take the exponent in the numerator and subtract off the exponent in the denominator because my bases are the same. So 1/2 minus 1 is a negative 1/2. Because it's a negative exponent, I'm going to put it in the denominator. So I'm going to write it as 1 over x to the 1/2. X to the 1/2 is the square root of x. How was that? All right. Coming back to my problem, I have the limit as x goes to infinity of 2 over the square root of x. And then over 1 minus 1 over the square root of x plus 1 over x. I'll wait. I'll wait. Now is the time to ask the questions.
Can you explain what you did in the denominator?
Okay. So I am subtracting exponents where I can. And so on the very first one here, x over x is 1, and that's where I get that.
And then the denominator is just x plus 2.
And then in the denominator, so the denominator started out with x minus the square root of x plus 1. So just like in the numerator, when I did this x to the 1/2 divided by x, I got the square root of x in the denominator. And the same thing is going to happen here. So what I did in the numerator is the same thing I did in the denominator. All right? Okay, cool. So what happens to my 2 over x, square root of x, as x gets very large? This part's going to go to 0. In the denominator, this part goes to 0, this part goes to 0. What I end up with, I end up with 0 over 1. Can I have 0 over 1? Absolutely. So where is this going then? It's going to 0. How is that one? So if I gave these two to you on the test, would you be able to replicate it?
With a little bit of practice, yes.
If you had to. Whew. Okay. Oh, this one. So go ahead and give this one a go. Don't look at me like that. Go ahead and give this one a go.